For the first question of the interview, could you sort an array for us? Yeah, fam, I got you. Print. Sorted. Hey. Ta-da!
Ta-da! It's the one and only Digo Double G. Snoop Dogg.
Are you tired of seeing the playing cards in the hand shtick? Not understanding the point of an algorithm when using plain old sort or sorted will do? Then welcome. So what's the point of understanding algorithms? Why is it good to understand how they work? I don't know. Why is anything good?
You might as well ask, why is the tree good? Why is the sunset good? Why are boobs good?
I'm kidding. I suppose we should understand a method's stability or performance. I mean, who cares if it's stable or the most efficient? Okay, let's get serious. Yes, of course we should care. It's important to know why, say, shifting is more expensive and why it's more expensive. The reason is because it requires more operations to take place. So when we swap instead, we eliminate those operations. So hopefully that explains a little bit why one algorithm could be better than another. So some might say that that's not true, but when you put it in the visualizer, it's 59 steps as opposed to 50 steps. So in my opinion, swapping is better than shifting. And we're going to get into all that and the difference between the two and which one I like better, because I like the swap because I don't have to use one of those nasty little while loops that if you haven't been here for long, you will know that I can't stand while loops, but it has a nested loop, so I don't mind those, that's fine. But we're going to do both of them, so let's get to it. So before we get into it, I did two little clips here that show the difference between shifting and swapping, because when it comes to the insertion sort, I know that they give the analogy of the playing cards, and I might be the only one who feels this way. And although it's a good analogy, I just feel like it kind of muddied the waters when it came to understanding this particular algorithm. What it boils down to, at least for me, is knowing the difference between shifting and swapping the elements in an array. Yes, we can use the playing cards as an example of holding them in your hands and splitting it from the first card and adding them in, but realistically speaking, it's kind of, I don't want to offend anybody, kind of a time waster, and when we could be actually explaining what's going on in the algorithm or the formula for sorting an array of small numbers, because the insertion sort is best with a small amount of elements. So when I was thinking in my head and trying to ignore the playing card scenario, I first of all thought, okay, how can I simply just swap all the elements in the array? So that's kind of where it started. In this example here, I'm gonna show you what I was thinking, like the train of thought that was going on through my head in order to get my brain to understand what I needed to do in order to sort this array. Basically, what it comes down to is when you're asked this type of question on an interview, you have to be able to solve it by understanding each and every step that has to happen in order to sort the array. I know that sounds very simple, kind of dumb even, but it's totally true. It's not just a matter of memorizing the code. Memorizing the code isn't going to help you. You have to understand how it works in order to be able to solve it, because what's the point of not being able to comprehend it? Like, you can memorize a whole bunch of things, but if you don't comprehend it, that is what makes all the difference in the world. Okay, so right here, what I wanted to start out with was just simply swapping the elements. So let's just make a function here, just define swap. And what you can do is to swap all the elements in an array. And this might seem really boring, and you're gonna want to fast forward this, but don't fast forward. Just to stay with me here on this. So if we wanted to just simply swap all the elements in an array, we could do this. So we have brackets, and then A1. This is going to swap every other element. And then what you're doing is you're just reassigning it so that, actually we can just copy this out here, make it faster. And then comma, it's going one way and then it's going the other way. And then all we have to do is return a, let's see, and then we just print the function here, swap. And let's run it. So if you could see here, this is kind of where I started. This was my starting point understanding, is that as you can see, each element is turned around within the formula. So this was kind of my starting point. Okay, so if we're swapping each and every element, what we want to do is swap it if it's lower than the other one, right? So that's kind of the basis for this. If you understand the swap of this function, you can build up from there. So that's where you can put in your if statements and all those things. Okay, so now that you kind of understand the swapping, I'm gonna erase this here. So this is kind of the foundation of how this is gonna go. So in order to do all of this, to swap, if a certain element meets a condition, we're going to have to loop through it. So for I in range, we're not going to start at index 0. We don't have to, because we're starting at the second number. We need to compare the second number with the first number to determine which way it's going to swap. So all we need to do is start at the first one over the entire length of the array. And then this part is kind of confusing what we need to do, in that we need to work down the array. And I'll explain what that looks like. Because this is the swap needs a nested for loop, we're gonna go for j in range. For j in range, we're going down the array, and I'll explain what that looks like and why we're doing that in a second. So because the range can have a start, I think it's a start, middle, end, or I forget what that is, if I remember correctly. Start, end, and the speed. Yes. How per step, I guess. Number of steps, if that makes sense. Okay, so we're gonna loop through. Okay, so what does this mean? I'm going to show you because I wrote it out on this document. I put a note over it so that you can't see it, because we're going to go over it step by step. In this for loop, we're going through, because the length of A is 6, and because we're starting at 1, it's only going to go through 5 iterations. Okay, so for each iteration, for j in range I minus 1, negative 1, negative 1, it's going to look like this. On the first iteration, it's going to stop at the 0 position. On the next iteration, see, it's going backwards. It goes 1, 0. So it's starting at, I don't have the array out here, but the array, and then it goes to 2, 1, 0, 3, 2, 1, 0. I think you get the point. And then it goes down like that. So that's how the loop iterations are working their way down. And you'll see this in the visualizer when I show you that. I know that this all seems like it doesn't make sense right at the moment, but it will when we start writing the formula. Right here, this is what the swapping is doing. I did record the visualizer as it goes through. As you can see here, the 2 gets swapped with the 5, the 4 gets swapped with the 5, and then it stays where it is and it moves up, and then the 1 gets swapped on its way down, and then it goes all the way to the end and takes the 3 and puts it into the place where it needs to be. Okay, now that we saw how this formula is going to work on the array, we're already halfway there of having it written. When we have the 2, we have a nested for loop right here. So once we have these 2 for loops written, this is where we put in our condition if. So if, let's see, if our current element is greater than the 1 next to it, j plus 1, this is where we tell it to swap. Let's see, actually, I'm just going to copy this out like this. Watch, it's really cool. Copy, paste, change this to a comma, and then put the equal sign there, and then we're just going to swap it. We're going to switch it around like that. I probably could type this out, but why would I do that? That's just silly. So if it meets the condition, it swaps. If it doesn't meet the condition, all we need to do is break, because we don't want to do anything with it. So I'm just going to break it out. And that's it. And then we need to, obviously, we need to return our sorted array. Now we're going to print. Ta-da! That's it. Hopefully you can see how this is working. So let's put it in the visualizer. Let's copy this out and we'll run it through. I might already have it in there. Let me close these tabs. Okay, I do. I have it in here. So let's start over. All right. Let's run it through. It's going to do our globals. It's going to start through our first iteration. It's going to start at 0 because it's going to start at the 5. And if the 5 is greater than 2, then swap it. And it is, so it's going to swap. Now it goes back up to the next one. Our second iteration right here is 5 greater than 4. It is, so we're going to swap it. And then it's going to go up to, it's going to go between the 5 and the 6. There is no swap, so it's going to break, and then it's going to go back and start it all over to the next iteration, which we are at 3, which is the 6. Is 6 greater than 1? It is. My bad, I'm ahead of myself. Okay, now we're going through, and the 1 is going down all the way down to the beginning, and then it's going to jump up to our 5th iteration, which is the 3, and start swapping all the way down. This is the beauty of the nested loop, which is the J, and the -1 decreases when the condition is met. And that's it. We have our sorted array by swapping the elements. So our next task is to not swap it, but shift it. And shifting is more expensive. And I think it's more code, which, again, who likes more code? Although shorter doesn't necessarily mean better. In this case, it kind of does. At least I think it does. So let's move on to shifting the elements and not swapping. Hey there! If you made it this far and enjoy what you're seeing, why not subscribe? I upload fresh content all the time. Thanks for watching. Okay, so when we shift elements, what we're doing is we're essentially copying the element that is larger, and we're copying it over into the next spot and then storing the smaller one in a variable. If that So as you can see on the screen, the 5, when it shifts over, it becomes 2 5s. And then the 2, I'm sorry, and then the variable 2, or whatever number is being stored in that variable, then gets put into the spot that it needs to go. Hopefully that makes sense. And when it iterates throughout the entire array, it's shifting elements, which in essence is just saying it's copying the element over into the next spot. It's storing the smaller number, and then when the time is right, that stored number gets put in the appropriate spot. The reason why this one is a little bit more expensive is because obviously there's more operations going on, and there's a nasty little while loop in it. So anyway, let's write the code, and I'll break it down and explain it as we go. Okay, so we're going to shift our elements instead of swapping them. So like I had said before, we need to, I don't remember, what did I say before? We need to loop through again, just like we do for every other type of formula for this kind of thing. Okay, so for I in range of, same thing, 1, we're starting at the first position, not 0th. Is that even a word? 0th position, according to the len of A. And then we need to create 2 variables for this because we have to store our current number in a variable. And then we also create another variable that is going to point to the one to the left of it. So we're going to make it key because that's what everybody else does. And I can't think of anything more clever. So we're just going to make our key our current number. And then J, again, I can't think of anything super cool to do that. So we're just going to make that J, which is to the left of it, which is I minus 1. And then we have to create our while loop. Oh, okay, so while J is greater than or equal to 0, because we're going up. And we have to make sure it says equal to 0 because we're working with Python. So if you're looking and studying these algorithms in basic stuff, I don't know, you have to put the equal sign in there because Python starts at 0, not 1. So keep that in mind. Okay, so, and we have to make this 2 conditions, and our number is greater than our current, which is the key, the current number. Now we're not swapping, we're shifting. Okay, so this is copying it over and then putting in our stored key into the position to the left, if that makes sense. So A, J plus 1, we're reassigning it to the current number. And then we will shift it, or put in our, not shift. And then, let's see, it's J. minus 1. And then we do A. Then if that doesn't happen, then we just reassign it as our, oops, we got to add 1 there. Equals our key. That's it. Let's see if we did it right. Does that look right to you? Looks pretty right to me. It's right. When these 2 conditions are met in the while loop, we're going to shift it over and then put our lower number to the left. And then if these 2 conditions are not met, then we reassign it to the current key. right? Does that make sense? While this is true and that is true. Okay. And that's it. Then we just return our arrays. Hopefully this makes sense. The difference between shifting and swapping. Oh, we were going to do the visualizer. So let's do that real quick. The visualizer, which is already in here. Let's start at the beginning and go through our globals. I'm going to go through this real fast. I might even fast forward this video, but no, the 5. Oh, we're shifting. We're not swapping. And then the 1 goes to 0 position. I don't know. Just ignore me. Just ignore me. Just watch the visualizer and you can see how this is working out. Okay. Some of you probably think I've been drinking, but it's 12:30. I probably could have a beer if I wanted to, but I won't. It's too early. Okay, that's it. We're done. Wait, oh, so the previous one. Our array is sorted. Well, thank you for joining me today. I hope you had a little bit of fun. I hope that this helped you a little bit. I don't know. I kind of feel like I have been drinking. Actually, I went to go take my daughter to work and my car wouldn't steer. Like the power steering was out. Like I thought I could steer it, but it was more like it wasn't happening. So she wasn't going to work. So it is spring break. She's home. But I did manage to get this film, and I was really eager to share the insertion sort algorithm. And I'm probably going to go through more the quick sort, the bubble sort, the merge sort, and learn them in the way that I learn, with the hope that maybe there are other people out there who learn the way that I do, and that sometimes the common way of teaching doesn't always work for everybody. For me, I have to find my own way of comprehending a certain formula or way of solving. And like I said in the very beginning, starting out at the base of just being able to swap the elements really helped a lot. I had to put the playing cards aside and kind of think about this. If I can swap the elements and then put a condition in there, that to me was easiest. If this number is less than the one next to it, then we tell it what to do. If it is less, do we swap it or do we break? That was really what helped me the most. So that's why I like the swap better versus the shifting, because the shifting with the extra operations, I don't know, it's more expensive. And in this case, the shorter code is the better code. So anyway, I would love to hear your thoughts. I would love to hear what you think about sorting algorithms and what has helped you. And let's chat in the comments down below. And anyway, that's it. Thanks for watching. Bye.